I don't want to open it 3 times. But oh, whoops. Uh-oh. My computer can't handle 3 PDFs at once. Okay, force.
Just before we start,
Yeah.
I wanted to ask. I saw when I was trying to solve this, and I googled a bit. I was looking at a similar question. They gave the initial speed.
Well, I did too. I just said they're at rest. You mean they gave a non-zero initial
yes.
speed? Yeah.
And then they were like, because they're going towards each other,
Yeah.
so they added their speeds, and they did distance over time, and then that's how they found the time.
That's only if it's not accelerating, I think. I'll have to have a look at the question, but just from the sounds of it, it sounds like a non-accelerating problem.
Yeah.
Okay, force. Force.
Okay.
Could you at least write the word force down? Thank you. Right. So we all understand the meaning of the word from just a day-to-day life experience, force. But what exactly is force? Not this. Before anyone asks. Not this. Okay. So, force. The formal physics definition of force. Now, you might have had different definitions depending on your high school. But the definition I go for is force is what changes the motion of an object. That is, force will change either the direction, the speed, or both. In other words, force causes an object to accelerate. So force is the cause of acceleration. Why does something accelerate? Because a force is causing it. This is the meaning of it. Now, this is kind of the key meaning of it. You don't have to write the next part down where I kind of elaborate a bit more. So the next part, which is not necessary for the definition. Although force can have other effects, such as changing the temperature or shape of an object, it is true to say that if an object is accelerated, then a force is being applied. And finally, force is a vector. So what you can see in bold here is kind of a key understanding. If an object is accelerating, then a force is being applied. There's no other way about it. If it's accelerating, there must be a force causing this acceleration. Things don't just accelerate. So the force is the cause. Okay. So you don't need this entire block of text. Try to write down what's most useful to you. The first sentence would be enough for the exam, for like an exam definition. But you might want to make some other notes of things as well. Okay, so I'll just give you a minute to make some notes here. I think it's also worth saying the first sentence and the last sentence. Force is a vector. That's important to know as well. Okay, can I continue? Yes? Did you hear from the other students my disgrace yesterday? Did you hear about my disgrace yesterday? No? Oh, it was disgraceful. I forgot about you. It was terrible. It was terrible. I said, who's not here? He said, Omar. Who? Omar. I'm like,
Go home and YouTube it.
yeah, when I upload the video, you'll see my embarrassment. And then they were trying to explain Omar. It's like, Omar's this. I'm like, no. Does he have glasses? I'm like, no. And they're like, oh yeah, now I remember.
He has a friend. You don't remember. I remember this friend.
Yeah, then I remember. Oh yeah, the friends with Ali. Yeah, okay, yeah. So don't take it personally. I'm very forgetful. Okay. So how do we measure force? I think you all know it's the Newton. But does anybody know, let me fix the screen a bit, does anybody know the definition of a Newton? A Newton of force?
By acceleration?
Yeah, kinda, but a bit more to it than that. I mean, that's Newton's formula. But what is the definition of the unit? Like if I said 1 Newton of force.
The amount
Yeah.
of force
Yes.
applied on an object
Yeah? Continue.
that causes it to move for in 1 meter per second square acceleration.
Yeah, come on, you're nearly there.
To be continued.
Okay, alright. So force is measured in newtons, the letter is N, and the definition is a newton of force is the amount of force required
To move
to
a
accelerate a 1 kilogram mass by 1 meter per second squared. This I've seen on the exam as a definition a couple of times, so it's worth noting that. And this is enough to get the full marks for the definition then. I wrote as well. The definition could be asked in the exam, so you should learn it off perfectly. Right? Okay, so you definitely want to write that definition down clearly. Got that? Yeah.
When do you upload the videos usually?
Depends. So like, I didn't have any time yesterday, and today I tried to upload them, but the process took so long I had to abort it because I needed to take the laptop to this class. So it might be tonight or tomorrow. Sometimes I just leave this running overnight to upload everything, because you know upload can be quite a long process. You probably know upload speed is not as quick as download speed, so it depends on how cooperative internet speed is being. I know I have a few videos to upload. There's like 5 or 6 of them to upload. Okay. Now, the relationship between force and acceleration is given by Newton's second law. We'll look at all 3 in time, but just for today we're having a look at Newton's second law, which relates force, mass and acceleration. One way to state this law is simply F equals ma. Knowing the F and the m can give you the a, or knowing the m and the a can give you the F, or whatever. This is Newton's second law, where F is the force being applied, m is the mass that has experienced the force, and a is the resultant acceleration. Now, you need the formula, but perhaps I need to be a little bit clearer here. A is the acceleration of the mass, m is the total mass, and F is the total force, which I didn't really emphasize here. So when you write down F equals ma, please also note beside it, this is total force, total mass, and acceleration.
M total force.
Yeah, m is total mass, F is total force, and A is acceleration. Oh, who was the student I heard that wanted to do cyber security? Is that you? Do you know any programming languages?
Learning.
Huh?
Learning Python.
Which one?
Python.
Nice.
And JavaScript.
JavaScript. I will start learning that next month. I've learned Python and C. I really like Python. I think it's great. How much have you learned?
Just beginning.
Just beginning, okay, yeah. Are you doing like videos online, are you watching, or are you just reading, or?
Just I found the tutorials on YouTube and watch.
Yeah, okay.
You're checking the new Boston.
Yeah, I can check.
The new Boston, yes, I've looked, when I was looking at Visual Basic, he seems to have lots of nice little programming videos.
I learned C in like a week and a half.
Yeah,
Plus your hours.
yeah, no, that New Boston channel looks great then for programming. Is that's the one you're using, New Boston?
Yeah.
Yeah.
One of them.
One of them, yeah, looks great. Okay. You can actually state Newton's laws in other ways. So if some of you are thinking back to high school and you're thinking, oh yeah, I heard Newton's second law state it differently. F equals ma is one way to state it, but there is another way which we'll look at later, and I wonder if anybody is remembering that way. I can give you the start of it. Force is the rate
Of change in velocity.
no. It's,
Rate of
yeah?
change.
Change of position.
No.
Mass.
No. Okay, no, forget it. Forget I said anything. We'll come to that later. For now, we'll use this formula. Now, the unit of force is the Newton. But we can actually write we can write the Newton a different way if we desire. So, we know that F equals ma. The unit here is Newton. The unit here,
AG.
kilograms. And the unit here, meters per second squared. So in fact, if you want, you could say 1 Newton is the same as 1 kilogram meter per second squared. That is perfectly fine to use this or this for force. Okay. You just need to know that in case you're reading some books online that maybe use this as the unit for force. Okay. Right. Okay, so here's a very simple one to practice F equals ma. In fact, you could nearly do it in your head. A 45 kilogram girl starts to run with acceleration of 2 meters per second squared. What is the force? 90 newtons. Yes, okay. F equals ma. It's 45 multiplied 2. Yeah. Right, now, let's see. Have we got... yeah. Oh, yeah, it's only 9:15. We have loads of time.
No, this one.
I know it's not 9:15. Now, come on. Give your teacher a break. I know he's a bit crazy, but you know, I really didn't think it was 9:15 a.m. Okay, so that first one is not really a question. It's this one here now that gets a bit more interesting. So we have 2 examples to do. You don't have to write all this text down, but if you could write down the information. So here you see a barista slide a cup of coffee across the table. The coffee is initially at rest, okay, and then leaves the hand at 30 centimeters per second. So think about it. It starts at rest and it starts to accelerate. So therefore, a force is being applied from the hand. It seems to be accelerating for 1 second. So in other words, I push it for 1 second. And you think the mass is roughly 500 grams. What is the force? Okay, so if you just want to write down the info, or you know what, I'll write it down and you can copy it. So here's the cup. U is 0, I said, and then somebody pushes it for 1 second. So the T is 1. The V is 0.3 when it's in meters. And finally, the mass is, I said, 500 grams, which is 0.5 kg. And we want the force. Okay, so do we know M? Yeah. Do we know A? No, but we can know it because we have enough here to know it. So what formula could give us the A here?
U minus V.
Yeah, you could go with V equal, yeah, the same thing. V equals U plus AT. 0.3 equals 0 plus 1A, because T is 1. So what's the A? 0.3 meters per second squared. So that's the A, that's the M. So the force would be 0.15 newtons. And to practice our prefixes, because you did prefixes today, yes, as evidenced by your notes, this would be 150 millinewtons. Now, I really will start using prefixes a lot in my answers, okay? You don't have to, but I think it's meter. So you have 150 millinewtons of force here. Yep. Okay, please write this one down. We'll do one more example and then we'll finish, okay? So like I said, not too difficult. It's really just F equals ma, which I would hope if you studied physics before you remember. It's like physics formula number 1.
So the equations we learned, we have to like memorize them.
You have a formula book, which I keep promising to put on Moodle and I haven't yet. But to be honest, I don't think this is a formula students should be checking in the exam. It would make me worried if someone had to check this. You know?
What, like the
F
V-
equals ma.
No, I'm talking about the V equals.
Oh yeah,
to
that's in the exam. But again, it would make me happier if you knew it. Okay. We got this? You're right. You got this, Omar? Yeah. Sorry, Nader. I think you're the last one. I'll have to go on. Okay. So I'll give you a minute to try this one. Very, very similar to the last one. Then I'll do it, and then that's it then. So it's a 1,200 kilogram car. Is traveling at 100 kilometers an hour. Then the car suddenly stops over 100 meters. What is the force? And the force is negative because decelerating. It's slowing down. Okay, so see what you can get here. So we know the U is 27.78, the V is 0, the S is 100. So what gives me the A easily?
V minus U.
Not
No,
quite
no,
this
no,
one,
yes,
yeah.
yes.
We'll go with V squared equals U squared plus 2AS.
Yeah.
0 equals 27.78 squared plus 200A. So then A equals minus 3.858 meters per second squared. Yes?
Yeah.
So how do I get the F? Well,
Okay.
multiply by M by A. So we have the A multiplied by 1200. And what did you get? Minus 4,630 newtons. Or, give it to me in kilonewtons,
Minus 1.3.
minus 4.63 kilonewtons. And that's it.
Okay.
So, homework, those questions. If you want to take a picture, you can. It's on Moodle. I'll close this in about 10 seconds. Yeah. Okay. I can tell you now there's a good chance that these won't be uploaded until tomorrow, because I want to go home now. Okay, got that? Right, off we go.